Namaskar, Adab, Shastrikar. Welcome back, students, to our revision series of PU2. So, in last lecture, if I will tell you, we have studied about capacitor. Capacitor is the ongoing topic, and now we have completed the two parts of capacitor. We have seen in complete depth. Even your NCERT doesn't include an extra chapter for capacitance, but we have studied capacitance in complete depth. It covers every basics from boards, if I will say, till JEE exam, NEET exam, KCET exam, all kind of things that we are covering here. Okay. So for this much of effort, at least you can like the videos. Okay. Thank you for that. Because we are putting a lot of hard work here for providing this much of quality content to the students. Okay. So now we are in the final part of the topic capacitor. Okay, capacitance. And in this one, we are going to basically discuss about dielectrics. What is dielectrics? From where does dielectrics is coming? Firstly, you have understood about dielectrics in the electrostatic chapter. In electrostatics, where I have introduced dielectrics, if you remember a very small thing that I have explained here, force in a medium. How many of you remember, students? Tell me in the chat section. How many of you remember about dielectrics? There I have explained a term, relative permittivity. Correct? I have explained your term, relative permittivity. Exactly that was what about, and this was that was what about dielectrics. That further it becomes dielectrics. Okay. I will tell you everything. I will tell you. Don't get worried. We are going to cover all the varieties. What kind of possibilities are there? What kind of radiation derivations can be asked? Everything we are going to understand completely. So without wasting any time, let's begin. Okay. So here is the topic dielectrics. Firstly, write this theoretical thing in your notebooks. I am hoping that all of you are making your own notebook. And what are the things you have to mention? I am telling you all the steps. If you are aiming at board exam, all the things, all the theoretical things that are written here are very, very important for you. Given things, diagrams, this is what you will, that will bring the thickness of your answer copy that you are writing in your final exam. And on the board exam, on the basis of that thickness, you will be getting your mark. It doesn't matter how accurate you are, but in board exam, what actually matters is how much the thickness of your. Obviously, you will not write any thing or write any song that you like in the paper, of course. But what you will get the marks for? You will get the marks for how much more lengthy answers you are writing, how descriptive you are writing, how to make any answer descriptive. In every lecture, I am telling you. And in NEET and J, you know, of course, directly the results are going to be applied. That also I am discussing here which result to remember, how to remember, when to apply some basic examples. Also, you will be watching here. So let's start. What is dielectric? Dielectric is an insulating material. Okay, it is what kind of body? Insulating body. It transmits electric effect without conducting. But it is an insulating body, but it conducts electric field without conducting. It transmits electric effect without conducting. There is no free movement of charges because already I have told you what kind of body it is. Insulating material. Dipole moment is induced in the molecules. Dipole moment is induced in the molecules. Now there are two types of dielectrics. One is called as polar dielectric. Second one is called as non-polar dielectric. Let's understand from types of dielectrics. First one is polar dielectric. Now what is the meaning of polar dielectric? The meaning of polar dielectric is dipoles are always already induced into the dielectric. And what is non-polar dielectric? Non-polar dielectric is dipoles are induced into the dielectric after induction. After when you are applying some external electric field, then electric dipoles will be induced. And what will be happening? Let's understand it a little bit. Anyways, the impact of inserting dielectric between the parallel plate capacitor, what will be the effects? Actually, it reduce the electric field. I will tell you how it is doing that also. So I will tell you about that also. Don't worry. Just listen me carefully, step by step. What is polar dielectric? Firstly, let's understand the definition because it is important for the board exam. The molecules of some dielectric have permanent electric dipole moments. I have told you that some dielectric will have its permanent electric dipole. What is dipole? Dipole is what a combination of same magnitude of positive and negative charge, and the distance between them is very, very small. Just like this. Here lots of dipoles are made. Okay. So they partially align themselves in the direction of external electric field applied. The external electric field that you have applied. Here is the external electric field applied. Firstly, what you have did, you have applied a pattern. Due to that, one point will get higher potential, second point will get lower potential. And electric field direction will be always from. I have told you what is the direction. from higher potential to lower potential. This will be the direction for electric field. Now if this is the direction of electric field, all the dipoles will align themselves in the same direction for electric field. Now if someone is asking me what is the net electric field, then what is the net electric field, how you will tell students? Net electric field is shown. I hope that my voice is clear. If any problem in the voice, then please tell me in the comment section. Okay. So if I will ask you, tell me what is the net electric field, how you will define external electric field is there from higher potential to lower potential, what will be happening inside? I can say I have already discussed it a little bit, but still let's discuss. Let's suppose there is a free electron. What will happen? This is the direction for that is what is the direction for the force? Force it will be this direction. If force at this direction, can you say all the electrons will be transmitted on this side? That means all the electrons will be collected here, and all the positive charges will be collected here. If all the positive charges are collected here and all the negative charges are collected here, what is the internal electric field? Internal electric field will be coming from again higher potential to lower potential. Again it will be coming from higher potential to lower potential. Is it clear? That means I can say this is the direction for internal electric field represented by E dash, and the external electric field is represented as E naught. That is the E. The net electric field is what? E is the net electric field. It can be written as E naught minus E dash. It can be written as E naught minus E dash. Okay. Now the second one is non-polar dielectric. Now what is non-polar dielectric? From the name itself it is very clear. The molecules acquire dipole moment by induction and placed in an external electric field like methane and benzene. You have to remember this result and diagram also you can draw. See here there is no dipole. Okay, until unless you are not connected. Until unless you are not connected this body, there is no dipole. Once you are connected, that means again what will happen? This will become higher potential, this will become lower potential. What will be happening? Electric field will be generating from higher potential to lower potential. If external electric field is from higher potential to lower potential, what you can say about internal electric field? Then some dipoles will be generated, and this kind of dielectric, this is dielectric. This is, you can say parallel plate capacitor is there, and you have inserted a dielectric. And what kind of dielectric it is? It is a kind of non-polar dielectric. So anyways, in question solving there is much role of this polar and non-polar. Just for a variety, I have told you, if let's suppose the question is asked in your board exam, then you can write the polar and non-polar. The main topic start from here. What is dielectric constant? What is dielectric constant? Students, you remember, let's take a quick recap. What I told you in the first chapter, let's relate it from here. What is Coulomb's force? Coulomb's force is what? F naught. It was equal to, let's write it in complete descriptive, 1 by 4 pi epsilon naught q1 q2 divided by r square. Correct? Now if I will ask you in medium, same Coulomb force in a medium, what I have told you I have to do there? q1 q2 will be same divided by r square. But here there was a term 4 pi epsilon. I have told you to multiply this epsilon naught divided into epsilon r. Epsilon naught into epsilon r. That means I have told you there, that means this complete term I think I can write it as f naught divided by epsilon r. Just divide anything by epsilon r, it will tell you the Coulomb's force in the medium. So what I have told you actually here, that epsilon can be written as epsilon naught into epsilon r. Epsilon naught can be written as epsilon naught into epsilon r. This is what relative permittivity. This is what permittivity of the medium, and this is permittivity of vacuum. Nothing but this epsilon r is called as what? Dielectric constant, and it can be described as epsilon divided by epsilon naught. It can be simply defined as K is equal to epsilon divided by epsilon naught. Is it clear? Now, after inserting a dielectric, what are the effects that is going to happen that we are going to understand? Let's suppose initially if there is no dielectric between the parallel plate capacitor, that is the normal parallel plate capacitor here. What is the capacitance? Capacitance originally I already have told you the formula. It is equal to A epsilon naught by D. What is the net electric field between them? Net electric field is equal to sigma divided by epsilon naught. What you can say about charge? Charge is equal to Q is equal to C into V, C naught into V naught. These are the original initial values that are there. Now what are the effects that will be coming on everything? On electric field also, on charge also, on capacitance also, on potential also, on energy also. every single thing we are going to understand step by step. So there are two cases. What are the two cases I will tell you? Firstly, the case 1, effect of inserting dielectric. Here what I can say about, see, on electric field, effect of dielectric on electric field. What will be happening on the electric? Initially, what is the electric field? Tell me, between the parallel plate capacitor, I have told you it is equal to sigma divided by epsilon naught. But now what is happening? You have inserted a dielectric into it. An insulating body you have inserted. Due to that insulating body, what will happen? After inserting, what will be the effect? What you will say? Your original electric field E naught, that is equal to sigma divided by epsilon naught, correct? But now what I have told you, that how you write epsilon or epsilon r, K is described as epsilon naught into epsilon r. What is it? Camera. Okay. So epsilon is defined as epsilon naught into epsilon r. So, and what is this epsilon r? It is nothing but K. That means K can be written as simply epsilon divided by epsilon naught, correct? So, at the place of here, epsilon naught just multiply and epsilon r, it will give you what? It will give you the electric field. Let's represent it in different manner so that it will be more clear to you. Electric field is defined as sigma divided by epsilon naught. Okay, a comment is there. Hello, Abhi sir. Okay, hi. Divided by epsilon naught multiplied by the dielectric constant, that will simply what is I am multiplying epsilon naught with epsilon r, and that will be the new electric field, that is E dash. So what I can say about E dash? Divided by K. That means, can I say that is the original electric field divided by K. That means what I can say, now the new electric field is reduced by a factor of K. It is reduced by a factor of K. Now this is the effect. Here you can see the net electric field between the parallel plates get reduced by a factor of K. Now what will be the effect on the potential difference? On the potential difference, how you write the effect? That is the next thing that we have to understand. So simply I can say that it will also get reduced by a factor of K. How it will be reduced? There are two ways to understand. Let's understand this one. What you can say about V, what relation between potential and electric field. For relation between potential and electric field, you say V is equal to E into D. V is equal to A into D. Now if I am saying initially this was V naught, this was electric field was E naught. Now what happened? V dash you can write E dash into D, new electric field. And how you define new electric field? E dash is equal to nothing but E naught divided by D, or sorry, E naught divided by K. So here also write E naught divided by K into D. That is what V dash. So can I say here nothing but also this? What is this E naught into D? E naught into D is original V naught, and V naught divided by K. V naught divided by K. So can I say also that my new potential is also decreased by a factor of what? New potential is also decreased by a factor of K. Is it clear? Is it clear to everyone? Yes or no? Comment section is live. You can comment also. If there is any doubt, I will be clearing your doubts in the live only. Now, next thing is, what is the effect of this dielectric on the net capacitance? What you can say, what is the effect? Initially, what was the capacitance? Net capacitance with the parallel plate capacitor. It was nothing but equal to A epsilon naught by D. So now what will be the effect? After inserting a dielectric, let's understand. What you say, capacitance is equal to A epsilon naught by D. A epsilon naught by D. Now, if now you are inserting a dielectric, what you write C dash. C dash is equal to what you write. You always multiply epsilon naught with the relative permittivity, and that relative permittivity we are defining as epsilon dielectric. So you will multiply epsilon naught into K divided by D. Now what I can conclude from here? This is what A epsilon naught by D. This is our original capacitance. Let's represent it as C naught, original capacitance, C naught into K. So what I can say about capacitance? That capacitance is not reduced. Capacitance have increased by a factor of what? capacitance have increased by a factor of K. Is it clear? Is it clear? Simply I can say C dash is equal to K C naught. So these are some basic effects that will be coming due to dielectric. Dielectric is an important part if I am talking about the competitive exams. So understand, it is very easy topic of dielectrics. Okay. Just wait and watch till the end. All the doubts will be simply clear in the live class only. Okay. Now already we have summarized all these things. E naught will become E naught by K. Potential V naught will become V naught by K. Capacitance C naught, if initially capacitance is C naught, it will become K C naught. K times it will increase, and charge compares if initially Q naught, finally it also Q naught. Because charge, what I have told you, it will also be varying. Let's see the two cases now. What will be the two cases? But before those two cases, let's first solve this basic question. That is for better understanding what we have studied till now. So we are taking some basic examples also, so that you can understand how to apply the formulas also. Tell me students how you will do. Firstly, what is the first step we always do? Firstly, we will read the question simply. Read the question step by step and write all the things that are given into the question at a single place. That is a method that we always follow. A parallel condenser. Condenser means I have already told you in the first lecture only that condenser is nothing but a capacitor with oil between the plate. Dielectric constant of K is equal to 2. Dielectric constant for the parallel capacitor is equals to 2. Has a capacitance C. If the oil is removed, the capacitance of the capacitor becomes. If the oil is removed, then what will be the capacitance? So if there is a dielectric, what you will say? C dash is equal to A epsilon naught by T. But since there is a dielectric, that means you have to multiply it by K also. That is what you will say, and K is equal to A epsilon naught by T. Correct? Because then now and what you can say about this? This is nothing but A epsilon naught by D can be written as C dash by 2, or the original or the initial capacitance divided by 2. Which option is giving you the correct answer? D option. Initial capacitance by 2. Because initial capacitance was represented as C, so the representation side should make it clear. And here now we are taking this as C dash. New capacitance is defined is C dash by initial capacitance C by 2. Simple? Is it simple? Correct. The answer will be C by 2. Here the explanation is also given. Now partially filled dielectrics. What will happen if you are inserting not the completely filled dielectric, it is partial filled dielectric. It is also possible. That means if this much of the thickness is there between the two parallel plates, I am inserting only half length of dielectric into it, and half of the length is only AL. This is also a possibility. So now in these cases, what will be happening? Let's understand. So the question is asking you, what will be the potential inside the capacitor? What will be the potential inside the capacitor? How I can write potential? I can write potential in terms of, because what is the relation between potential and electric field? Potential simply can be written as E dot D. What is the electric field in that region, and into multiplied with the thickness of that region. Okay. So now if I explain you, this question will be divided into two sections. What will be the thickness of this section? It can be written as G minus T, and what is the thickness of the dielectric section? It is nothing but equals to T. So let's patiently write everything and try to understand. What I can write? What is the electric field in this region? I know that electric field in this region, I should take a different color. Electric field into this region is nothing but sigma divided by epsilon naught. What is the electric field into this region? Sigma divided by epsilon naught. Divided by epsilon naught. And what is the thickness of this region? This is nothing but D minus T. This is the thickness, that is D minus T. Plus, now what is the electric field, and to D you will write here. For this section, this is V1, this is V2. I will write V2, E into V2. Now I will write electric field for this one. You will write sigma divided by epsilon naught into multiplied by K also, because now there is a dielectric medium, that means you have to multiply epsilon naught with K. Now it is multiplied by a factor T. It will multiply by a factor T, because the thickness is what? T for the section. So let's see what is the result that is coming. I can take sigma by epsilon naught as common and bracket what will have here d minus t, and here what is that plus of t by k. This is the net potential that will be there. I can write sigma divided by epsilon naught d minus t plus t by k. Now if you want to remove this sigma, what you can write at the place of sigma? You can write also here as q divided by a charge by area is what defined as sigma. Is it clear? Now second thing is capacitance of the partially filled capacitance. Partially filled that dielectric, it should be here dielectric. The partially filled dielectric, what is the capacitance for that dielectric? Okay. So how you write? Firstly check, this is surface 1, this is surface 2. What you can write for capacitance? Capacitance can be written as charge divided by equivalent potential difference across whatever the V you have calculated. Simply, what is the charge you write? Q divided by potential. How much potential you have written? I am writing in the form of charges now. I will write Q divided by A epsilon naught in bracket D minus T plus of T by K. Is it clear? Now, what you do? This Q's will be simply get cancelled out, and in the numerator it will become A epsilon naught. In the denominator it will be D minus T plus of T by K. A epsilon naught by D minus T plus of T by K. Correct? So let's see. Is it correct? A epsilon naught divided by D minus T plus T by K. Correct? And here it will be Q divided by A epsilon naught in bracket D minus T plus T by K. Is it clear? Is it clear? So these notes will be available to you, all the derivations that I am doing on the board. Either you can take screenshot from there, you can make your own notes, and if you want, you can tell me in the comment sections. Those students will be telling in the comment section that they want the notes. It will be provided to all of the students. Don't worry for that. Now for the result that you are getting, what will be the result? Condition, just a condition is generated when thickness is equal to 0, and second one is when thickness is equal to d. What will be happening when the thickness will be changing? If thickness is equal to 0 in this formula, what will be happening? Thickness is equal to 0, that means what I can say, what is the thickness of this dielectric? 0. If there is no dielectric, what is the already, we know the formula capacitance is equal to A epsilon naught by D. So let's cross check it. Our formula is also giving the same thing formula. T is equal to 0, that means this term is 0, this term is 0. What is that? Can I say nothing but students? A epsilon naught by D, that is correct. Exactly, our formula is also giving you the same thing. Is it true also? Correct. Now you can believe this formula. Okay, this formula is not fake, it is giving you correct. Now if I ask you that it is not partially filled, it is completely filled, that means then what will be the thickness? Thickness I can write it T is equal to D. And at that condition, what you write the capacitance? You say that, sir, I multiply epsilon naught by K only divided by D. This is what you do. Okay. So when it is T is equal to D, what is, let's make T is equal to D in this formula and let's cross check it. What is the C that I have written here? A epsilon naught divided by D minus T plus of T by K. Right? Now put T is equal to D because you have made the complete thickness. You will write D minus T plus of D by K. D cancel. What you will be getting? A epsilon naught into K divided by D. And can I say exactly the same result is coming? Correct. That means our formula is completely correct. We have cross checked it also. We have satisfied the two cases, two extreme cases. Either we are inserting the dielectric, either we are not inserting the dielectric. That means thickness is equal to 0. And if we are inserting it for completely, not partially, completely, if we are filling it, then the result is also correct. That means we have verified it for both the things. Okay. Now, series combination for partially filled dielectrics. Now, how you will judge? First question is, how you will be judging that is it a series combination and parallel combination in partially filled dielectrics? Very simple thing. For series and parallel, you don't have to think anything. Nothing is there. I told you only. Just remember two things. For parallel combination, potential difference is always same. For series combination, potential difference is different. This is the section connection that we will be making. Let's have some batteries connected. One will be at zero potential, one will be at D potential. Okay. Now a dielectric insert. That means I can say this plate is at potential V, this plate is at potential 0. Correct? Now this is going to behave like a capacitance C1 and this one is going to behave like a capacitance C2. And what you can say about the magnitudes also, let's write it. What you write for the capacitance of this one? You will write A epsilon naught divided by, what is the thickness of this much? This will be D minus T. A epsilon naught by D. What you write the capacitance for this one? You will write capacitance for this one will be equals to simply A epsilon naught, but there is a dielectric also, that means you will multiply it by K divided by the thickness, that is equals to T. Correct? Now these two capacitances. Now tell me what will be the, do you know the potential at the half section? No. Let's assume that it is some X. Let's assume this is X. So now I will ask you a very simple question that I am asking you from the second lecture only, that what is the potential difference across C1? Can you say potential difference across C1 is V minus X, and what is the potential difference across C2? Can you say X minus 0? That means can you say, is it true to say that potential difference across both these capacitors are not same, they are different? If potential difference is different, that means what kind of combination, students, you are having? Series combination. And what is the formula of series combination of capacitance? Correct. It is the formula of parallel from the resistance topic. Correct. Don't get confused. What is the formula that you will write? You will write 1 by C equivalent is equal to 1 by C1 plus 1 by C2. 1 by C1 plus 1 by C2. Now let's put the formulas carefully. C1, how much you have written students? C1 is A1 by C1 is equal to A epsilon naught. In numerator it will be going D minus T. Correct? Plus 1 by C2. 1 by C2, how much you will write? A epsilon naught and multiplied by K, and in the numerator it will be going the thickness T. Now make a summation. What you will do? Take 1 by A epsilon naught as common, and in bracket what is left here? Here it is left D minus T from here, and here it is left T by K. Here it is left what? T by K. Correct? So this will be equals to how much? 1 by C equivalent. It is nothing but equals to 1 by C equivalent. This is the result. Is it clear? Is it clear to all of you? So you can see 1 by C is equal to by A epsilon naught minus C plus T by K. Or if you directly wants to write, if you directly wants to write C equivalent, you can take this complete thing in denominator. C equivalent completely you can write. Take this denominator A epsilon naught and take this complete expression T minus C plus T by K in denominator. D minus T plus T by K in the denominator and make it K epsilon naught in the numerator. This is the formula. If you want to remember, you can remember. This is the standard result, I will say. Need students specifically, if any need students aspirant is there, it is mandatory for you to remember this formula. For JA students also, I will suggest that remember the formula. Otherwise, you people have that much of sufficient time as well as a little bit of mental ability also to solve the question. For need students, because there is only 1 minute for every question, that is better if you are remembering the results directly. And for board students, you have to remember the complete thing anyways. So this is the same result that we have already seen. Now what will be happening if I am introducing such n number of dielectrics into series combination? What will happen? The same formula that we have written. What is the equivalent capacitance that we have written? C equivalent that we have written was equal to A epsilon naught divided by D minus T plus of T by K. Am I right? If I am wrong, then please correct me students. D minus T plus T by K. Correct? Now if n number of things are added here, n number of dielectrics are added here, it will have some thickness T1, it will have some thickness T2 till where? TL. TL, that is the net final thickness is TL, and the dielectric constant is K1, K2 and K3, K4, K5 until where? Kn. How do you write the same formula? You will write same formula as A epsilon naught divided by T minus. Here do the sum of all the thickness T1 plus T2 plus T3 till you will do till Tn plus. Now what you will do here? You will do T1 by K1 plus T2 by K2 plus T3 by K3 till where you will do the same thing till Tn divided Now it is completely filled. Two different areas I filled, and I named it will be behaving like some C1, it is going to behave like some C2. Now it is completely filled with two different capacitance. So what you can say again, I do the first I identify what kind of combination it is for identifying zero potential. This potential, suppose I know that's going to get some exponential. If I ask you the potential difference across C1, what you will say? V minus x. If I ask you the potential difference across C2, what you will say? X minus 0. V minus x and x minus 0. That is potential difference is different. If potential difference is different, that is what kind of series combination. And if it is series combination, I can make this diagram looking like this also. I can say simply 1 by C is equal to 1 by C1 plus 1 by C2. That is C equal to also C1 C2 divided by C1 plus C2. Okay. Now here terms are defined. So if you want, again you can write the complete thing. What you can do, if you want to write, you can write it completely also. Here what is C1 C2, again the same kind of things. You will be writing 1 by C equals to 1 by C1. C1 is what you will write it as A epsilon naught into K1 divided by T1. What you will write here? A epsilon naught into K1, and here it is T1 plus, here what you write? The thickness is T2 divided by A epsilon naught into K2. That is what you can say. You will take 1 by A epsilon naught as common, and then 1 by K1 plus C2 by K2. Correct? And let's suppose if I have to write C equivalent, how I will be writing? I'm using there is no sufficient space here, that's why I'm writing here. C equivalent you can write, take A epsilon naught in numerator, and in denominator what you write? You will write T1 by K1 plus T2 by K2. And now what will happen? If let's suppose not two dielectrics are there, three dielectrics are there, then what you will do? You will write here T3 by K3. Let's suppose if there is not 3, there is 4. Then what you will do? You will write P4 by K4 till where? Till Tn divided by K. Is it clear? This is what you will write for series combination. Exactly the same thing. Now it depends how you are writing. Either you are writing 1 by C equivalent, either you are writing directly C equivalent. It's completely your choice according to the question. You can switch that. Now let's see a little bit about parallel combinations also. This is how parallel combinations looks like. Firstly, understand how it will be looking like, and how I will be judging that it is a parallel combination. That is more important. Parallel combination potential difference same. Series combination potential difference different. Correct? Now this thing should be now remembered into your mind. I don't know how many times I have dictated this thing. Now how we judge it? Always we write the potentials. This is the kind of combination. This is C1 K1 inserted. This is C2 K2 inserted. This time thicknesses, if I will ask you one thing, that can I say that thickness are same for both them? So what is changing? I can say this time area is changing. Area is what? This is the cross section area that is present. Can you say this time area is A1 for this, and this time area is A2. Till now we have not discussed for area, because in series combination areas were same. What is changing? Thickness was changing, but this time in parallel combination what will be changing? Area is changing and thickness is same. Now, if I ask you to name the potentials, one will be at higher potential. Let's suppose this is V, this is 0. I hope that this is visible to you. Now, if I ask you, tell me what the potential difference across C1, what you will write? V minus 0. If I ask you the potential difference across C2, again you will say V minus 0. So, can you say potential difference is same? That means what kind of combination, students? Tell me. Parallel combination, correct. In parallel combination, I can draw this, and what I can say simply parallel combination is it is nothing but equal to C1 plus C2. And how you write C1? Let's write also. C1 as A epsilon naught. What is the dielectric constant? K1 is multiplied by K1 also. Divided by what is the thickness? Or actually, I should write it as A1, not the complete A1. A1 is given, and the thickness I am going to use is D. D is the complete net thickness that is given. Plus C2. I will write C2 A2 epsilon naught into K2 divided by D. Correct? Now take the things that are coming common. What are the things that are coming common? You can take epsilon naught by D as common, and then there is a factor A1 plus A2. And now Is it clear? Is it clear, students? If any doubt, please tell me in the comment section. Comment section, I am continuously watching. If there is no doubt, we will be taking that doubt here only. Actually, not ready. Then there is a factor of a1, k1, a2, k2 till where an, kn, whatever the number of directories you are inserting in parallel combination. So now there is a question. Let's try to resolve this question. Basic question. Okay. A parallel plate capacitor has two layers of directories as shown in the figure. Figure is giving you everything. This capacitor is connected across a battery. Then the ratio of potential difference across the dielectric layers is. What will be the ratio of potential difference across the dielectric layers? That means what you have to do, you have to, let's suppose potential difference is V1 for this, let's suppose potential difference is V2 for this. And what I have to do, I have to take the ratio. Okay. So let's see. Firstly, what I can write, tell me what is the capacitance I will write for this one. For C1, what I will write the capacitance? I will write what is the D here. What is the formula? Capacitance formula is nothing but it is equal to A epsilon naught by D. So firstly, patiently write without rushing anything. What will be the capacitance? You will write A, the cross sectional area, into epsilon naught multiplied by K, that is 2, divided by what is the thing is given? D. Correct? And let's suppose this K epsilon naught by D is some C naught, that is what I will write for this. This is nothing but equals to 2 C naught. This is nothing but equals to 2 C naught. What I will write for capacitor 2? How much capacitance is there? What I will write? Because it is a series combination, area will be same. I have already told you. This is the same cross section area. This is the same cross section area. A epsilon naught into what is the dielectric constant? 6 divided by what is the thickness? You will say it is nothing but equal to 2D. That means this 2 and this 6 will be cancelled. That means what is the now net thing is coming? I can say 3 is the factor that is left, and I am defining A epsilon naught by D as C naught. That is C1 is equal to 2 C naught. C2 is equal to 3 C naught. This is what we have calculated only the capacitance. Now the question is asking me to take the ratio of potential. How you will do? What is potential? V is equal to Q by C. V is equal to Q by C. That means if I am doing V1 by V2 and I am saying that charges are same, that means what I can say it is inversely proportional. That means it will become C2 by C1. And what is C2? C2 is nothing but equal to 3 C0. What is C1? It is nothing but equal to 2 C0. C0 cancel. What is the minus thing that is left? 3 by 2. 3 by 2 which option correct? D option is students coming correct. Is it clear? Simply I have written, I have calculated basically the capacitance, and then potential difference was asking. I know the definition or the formula of potential difference even from the first lecture. Is it clear? Correct. Now let's move to the next one. Same answer. 3 by 2 is the final answer. D option will be correct. Here the complete solution. This is the way how you have to write the solution. I am explaining according to the, I am just finding the answers, but in exam you have to write this much of theoretical things for having a grade marks. Okay. Now, so there will be no scope for the checker, that the person who is checking the copy, that they can cut any single marks even from your paper. Is it clear? So now insertion of dielectrics. When you are inserting a dielectrics, there are two kind of cases that will be possible from where questions will be asked. First case will be, let's suppose your parallel capacitor is there and you have connected by some battery nucleus. Okay. So there will be two cases. First case, question can be asked that you are inserting a dielectric inside the parallel plate capacitor and it is connected to the some battery potential difference, and that is still connected after inserting also. Second case be that after inserting dielectric, battery will be removed. Battery will be removed, and in both cases the variations that will be coming in what are the things we are checking the variations in charge, in capacitance, in electric field, in potential, in energy. All these 5 parameters we are going to discuss for both these cases. Once battery will be remains connected, second case battery will be removed. Let's see for both the cases. Just be here. Case 1, battery is inserted and then if dielectric is inserted and battery is disconnected. Case 1 is when battery is disconnected. You have inserted a dielectric into the parallel plate capacitor and you have removed the battery. If you have removed the battery, what will happen? One thing you have to understand, only single thing I will ask you to remember. Only single thing. When you remove the battery, what happens? Actually, charge remains constant. Because if there is no potential difference across the capacitor, that means there is no electric field that will be taking the charge. Transfer of charge happens when you have connected the battery, but Now initial charge will be how much? Q naught, and final charge will also be Q naught, because I said that what? Charge is going to be constant. Next, capacitance. Initially capacitance is equal to how much? Initially capacitance is equal to A epsilon naught by D when you have not inserted the dielectric. But what will be the final capacitance when you have inserted the dielectric? You will write A epsilon naught by D, but what will be multiplied with epsilon naught? Now it will be multiplied this factor K dielectric. That is what I can say this students. It is nothing but this complete thing is C naught. That means what I will write this will become actually K C naught. That means capacitance have increased by a time how much times? It is increased by a factor of K. It is increased by a factor of K. Is it clear? Second thing. Now let's discuss about potential. How potential will be changed. I can say for potential V is equal to Q by C. Right? So initially what I will say Q naught divided by C naught. This is before inserting. After inserting what I will say, let's suppose this is V naught. I will write V dash. This is for capacitance. V dash I will write Q naught, that is constant. But what is C dash? What is the new capacitance? I can say it is nothing but equal to K C naught. Now what is this Q naught by C naught? It is nothing but equal to V naught by K. That means can I say what is happening with my potential? It is reduced by a factor of K. So it is reduced by a factor of K. Final potential is V naught by K. Is it clear? I am running a little bit of things so that now I hope that you have made the notes for this. Otherwise it is live. You can rewatch this on our app also. Correct? Now see, next stage. Let's understand the next. What will be happening with the electric field? What will be happening with the electric field? I can say two ways are to understanding for electric field. What are the two ways? Electric field between a value plate capacitor before inserting is how much? Sigma divided by epsilon naught. Simply from a lot of time you are learning this. But after inserting a dielectric, what will be E dash? E dash will be equal to sigma divided by epsilon naught will be same, but you have to multiply epsilon naught with K because now you have inserted a dielectric. That means now can I say it will be reduced by a factor of K. It is reduced by a factor of K. Now there is one more way to understand for this. What is the second way you I can say? I can say that V is equal to E to D. Correct? Correct now? And initially if I am taking before inserting, I will write V naught is equal to E naught into D. Initial electric field into D. Finally what I will say? Finally I can say how much it becomes. It is also reduced by a factor of A. V naught by K is equal to some E dash into D. Correct? So now if I will be comparing both these cases, can I say if this is becoming V naught by K and this is remaining same, you can take the ratio also. Can I say E dash will also become E naught by K? E dash will become E naught by K. If you don't trust me, you can take the ratio. Okay, why to trust me? When you can take the ratio, then do it. Take the ratio. What will be there? V naught will be cancel out, and here it will become K, and here it is what? E naught divided by E dash. That means can I say E dash is equal to nothing but E naught divided by K. Now you trust me? Correct? Is there any trust still? Okay. Now let's analyze the next case, that is for final, that is energy. What will be happening with energy? Now for energy I can say formula is Q square by 2C. Simply this is, if it is initial I will write Q naught and here it is C naught. If I am writing the final energy, what I will write? Q naught, that is constant, divided by 2. What is the new capacitance? I can say it is nothing but equal to K C naught. That means rest of the things are same. That means U naught divided by only extra factor, that is not final, that is K. That means energy is also reduced by a factor of K. Is it clear? What are the changes that are happening? Are you noticing these patterns? This was for case 1. For case 2, what will be happening? Case 2 is what? Dielectric is inserted, that is fine. But battery also remains connected. And in these kind of scenarios, what will be happening? Let's understand. Now this time you have to remember a simple thing, that V naught is equal to constant. V naught is equal to constant. Okay. So let's see. Firstly, let's judge for capacitance. Capacitance, what I can say initially, C naught is equal to A epsilon naught by D. A epsilon naught by D. If initially it is A epsilon naught by D, finally what when I am writing, I will write A epsilon naught by D, but you have to multiply our capacitance by electric constant K also. then finally again it becomes Kc naught. That means there is no change in the capacitance. I will say there is no change in capacitance. Now what will be the effect on the charge? That is interesting. Why I write charge Q is equal to, let's suppose initial time Q is equal to C naught into V naught. And now what is constant? V naught is constant. That means if I am writing the final charge, how I will be writing? I will write C naught at the place of now what is the new capacitance? It will become AC naught into, and now what I can write about V naught? V naught is going to be same. That's what I can say. It will be equals to K Q naught. Final charge will be equals to K Q naught. That means charge is also increased by what factor? It is increased by a factor of K. Is it clear? Now let's discuss about the third one, that is electric field. What you can say about electric field? Correct. If I am going by the maybe you will be thinking that I will say there will be no change in electric field. Correct. But maybe you will have a doubt. What is the doubt that you can have? Let's understand that also. For a moment, I will be rubbing this thing. Okay, let's shift. For a moment, I am rubbing this. What is the doubt you can have? You will be watching that. There will be no change in electric field. I will prove that also. What is electric field? E naught. You will say, sir, it is nothing but equal to sigma divided by epsilon naught. Correct? Sigma divided by epsilon naught. Now, when I am writing it as final electric field, what you will write? Sigma divided by K times of epsilon naught. K times of epsilon naught. Now you will be saying, sir, how you can say that it is going to be constant? Because it is reduced by a factor of K. Do you also feel this doubt? Yes or no? I know that where you are going to start. But you are not focused. What is sigma? Sigma, if you are writing properly, you will write it as Q divided by A into epsilon naught. Correct? And here, if you are writing this properly, you will write Q final divided by K times of epsilon. And what is the charge final? It is multiplied by a factor of K. K Q naught divided by K epsilon naught. This K will get cancelled, and I can say, and here is obviously a factor of K. That means I can say finally also it is equals to my initial electric field. There is no change in the electric field, I will tell students, because what is happening? Initially, here was a factor of K epsilon, but we have not noticed that there is a factor of K multiplied by the charge also when we are writing it for finally. Is it clear? So there is a table that you have to remember. Correct? Now, what will be happening with the energy? Let's understand also energy via forward. Initially, writing energy, what will be half C naught V naught square. Finally, when you will be writing energy, what will come? Because V naught square is going to be constant, only change will be coming here half C naught V naught square. That is, I can say it will become K times of V naught. That is, energy is going to be increasing in this case too. So these two are the important cases, most important cases from where questions have been asked. We have to mention, you have to watch properly that which case it is given. Don't get confused, don't apply the different case, because that's why I have explained it from the complete basics. In first one, what you will remember, that charge is constant, and when batteries remains connected, what you will do, potential is connected, it will remains constant. Once you understand this much of these two lines, everything you can write, even at the moment also, you don't have to remember everything. Okay? At the moment also, if the concepts are good, you can derive everything. Is it clear? Now, the last case, if it is coming, sometimes if it is can be asked how much is the net force that is acting, I will explain you quickly. When you are inserting a dielectric, when here it is a diagram that have been drawn. Here is a parallel plate capacitor. This length is B. This side is given as A. The thickness is given as D. And you have inserted this dielectric till distance X. What will be the force that will be acting on the dielectric? That is what we have to understand. Because there is some force that will be applied on the dielectric. How much that force will be to insert this dielectric? Okay. So you will be reading this theoretical things. I am explaining you how you will be calculating. So when it is inserted this much only at till distance X, okay, there is complete length also, but you have inserted as a moment, and the moment that I am taking only distance X. So I can say inside the parallel plate what will be happening, it will be behaving like two capacitors, capacitor 1 and capacitor 2, correct? It is going to behave like capacitor 1 and capacitor 2. Two capacitors to judge the combination, students? I am going to always follow the potential rule. Write the potential here. If this is a higher potential, if this is a lower potential, I will say this is at zero potential, this is at V potential. And I will say for both of them, potential difference is going to be same. Potential difference is going to be same. But areas will be changing now because it is connected in parallel. Remember the thing. If it is connected in parallel, areas are changing. How I am going to write patiently. Firstly, write C1. C1 because there is no space. Let's write it. C1 how you write? You will write what is the formula of C1. I have told you C1 is this one where air is present. I will write simply area. How you write the area? Area of cross section. I will write B into what is the length for this much of section? I can say A minus X. So how I am going to write C1? C1 I will write B into A minus X. Area is the length into breadth into epsilon naught divided by, because I will not multiply by K because it is air only, divided by the thickness. Thickness is how much? D. This is what C1 I will write. Then I will write C2. I will write C2. How I will write C2? That was one. Tell me what is cross sectional area. Cross sectional area, how you can write? You will write what is the distance, that is D. What is the thickness, that is B. That is how you write the area. B into X, that is the area, divided by epsilon into multiplied by epsilon naught. And not only epsilon because it is a dielectric constant, that means K is also there. Right? K divided by D. Correct? The areas are different, already I have told you. And what kind of combination it is? Series parallel combination. Parallel combination, that means what will be the C equivalent if I will calculate? C equivalent will be simply C1 plus C2. C1 plus C2. That means what will be the C effective? I will simply say just add up both of them, and finally after adding both of them, this is the result that you will get. But the work is not done yet, because what I am trying to calculate, I am trying to calculate the net force acting on the dielectric. Okay, so let's see what is the net force. Take the result from there. What is the formula? C effective is equal to let's take this pen. It is B epsilon naught by D. Tell me the students the result that is we are getting. It is C effective that we have calculated. It is equal to B epsilon naught by D in bracket. Then what is there? Let's see. A plus K minus 1 X. Correct. It is A plus K minus 1 X. This is the total result that C effective we have calculated. Okay, fine. Now I will ask you students, tell me, can you write what is the potential energy that will be stored between the parallel plates? You will say simply such formula is half into C effective into V square, because the battery that was connected was V square. Okay. So how you write half into multiplied by what is C equivalent that we have calculated, students? B epsilon naught by D bracket A plus K minus 1 into X into V square. That was a battery potential that we have connected here. Now if I ask you, tell me what will be the force. From energy we know what is the relation of force. We will know very well how much the force relation is. From energy it is equal to minus of du by dl, where we have studied firstly in work power energy. Are you remembering? So this formula will be helping us for finding the relation between force and potential energy minus of du by dl. Or here what is the variable? Distance is x, so I will write simply du by dx. Minus sign is there outside. Now tell me, differentiation of x. Rest of the things are constant, so take the constants out of integration. You will write half b epsilon by d into v square as constant, that is out of integration. Now here differentiation is only for this much of the term. This much of the term, because I hope that you know about differentiation. Basic differentiation is present, only x term is here. What is the differentiation of a? It will be nothing but equals to 0 plus what is the differentiation of x? It is going to be 1, and here it is constant multiplied, that means here in the bracket it will be coming k minus 1. So what I can say about the force, students, finally our force is coming, because it was a long process. After that we have got force. Force is equal to B epsilon naught V square by D k minus 1. This is the formula that you will be getting. Now I will suggest that remember this formula, because once in JEE exam directly this formula was also applied into the question. 4 options were given, and the right formula question was asked for you. So I will suggest that you can remember this result, and for both students obviously you have to remember. We can see this is the potential energy, and finally after differentiating this term k minus 1 d v naught square epsilon naught divided by 2d, this is the result that you will be getting. Is it clear? So this is what about this topic. Okay. Right now half c naught correct. I guess we have used a factor of 2 because here it is will be half will be also there. So multiply a factor of 2 in the final result if it was by chance missed. Otherwise the formula will be as remains same. So this was it about this chapter capacitance. Now we have completed the first portion of U2 syllabus completely, that was comprised by electric charges. We have started. Then we have studied about potential, electric potential, and now the final topic capacitance we have studied in complete depth. And we have seen all the varieties that can come from capacitance for all the exams, competitive exams. You can refer this for any kind of competitive exams. We will covering everything. So until next time, keep learning, keep growing with tapasya, endigu, and then digu, namma tapasya.